Okay, so with the derivatives of these trig functions, we can evaluate the derivatives of functions that are the product of expressions involving trig functions, and also the division or the quotient of expressions involving trig functions. So for example, if we're looking at A right here, we've got the function y equals x squared times secant x, and right here our x squared could be considered our u, and our secant x could be considered our v, and to take the derivative of the product of these two expressions, we would need to use the product rule, right? Which says that our derivative, dy dx, is going to be of the form u prime v plus u v prime. So right here, taking the derivative of this guy, we would say we've got dy dx equals, and now right here we would say the derivative of x squared times secant is going to be our u prime v. So right here we would have 2x and then times secant x, and then right here plus, and right here we've got our uv prime, so that's going to be our u of x squared times our v prime, which is going to be the derivative of secant, which is secant x tan x. So right here we've got our u as x squared, and then our v prime as secant x tan x. And that would be the derivative of this product, right? So looking at C, we can say that we've got a division of two expressions involving trig functions. We've got cosine in the numerator and 1 minus sine x in the denominator. And here we can see that our numerator would be our u and our denominator would be our v for the quotient rule. The quotient rule says that our derivative is going to be of the form dy dx equals, and then we have u prime v minus u v prime over v squared, right? So taking the derivative here, we're going to say we've got dy dx equals, and now it's going to be the derivative of the numerator times the denominator. So derivative of cosine is going to be negative sine x, and then times the denominator, which is 1 minus sine x. And then we've got our minus uv prime, right? So our u is our cosine x, and our v prime is going to be the derivative of the denominator. Now right here I can say the derivative of 1 minus sine x is going to be the derivative of 1 minus the derivative of sine x. So the derivative of 1 is 0. The derivative of minus sine x is going to be minus cosine x. And that's all over our denominator squared, so that's 1 minus sine x squared. Now, there's a lot more simplifying we can do here. Right here, for our second term in the numerator, we've got a cosine times a cosine, so pretty easily we could make that cosine squared. And since we're multiplying a negative and a positive and subtracting, we can see those negatives canceling out, so that would be a positive cosine squared x. And similarly, right here with the first term, when we multiply a negative sine x and a negative sine x, we would get plus sine x squared when we're multiplying those first two parentheses out. We're not going to do that simplifying, but what we'll see when we start doing some of that is we can condense these expressions way down with identities. So right here, we're going to leave that for now, and we're going to have you guys try B and D. Right here with B, we've got the product of tan x and sine x, so you're going to want to use the product rule there, where U is going to be tan x and V is going to be sine x. And right here with D, we've got 4 over cotan. Now right here we can attack this with the quotient rule, where our U is 4 and our cotan is our V. But there's also a simplification you can do before taking the derivative, which would make it much faster. But if you can't see that, just look at it with the quotient rule, and we'll come back and look at these in a second. All right, guys. So looking at these, when we look at B, we can, of course, use the product rule here. So we've got our U as tan, our sine is V. So right here, that's going to be U prime V as the derivative of tan times sine. So that's secant squared sine x, and then plus U V prime, which is our tan, and then the derivative of sine, which is negative cosine x. And right here, there's some condensing we could do here and simplifying we could do actually with with some basic identities rather. But we're going to leave this for now. We'll talk about that more in class. Now right here with D, we've got our quotient or our division as 4 divided by cotan. And right here with our quotient rule, we can see that our numerator is going to be u prime v minus u v prime. Right here, the derivative of the numerator, 4, is 0, so that's our u prime, and then times our v, our denominator of cotan x, and then we've got minus, and then it's 4 times, and right here, what did I forget? This is a negative cosecant. So right here, 4 times, and then the derivative of our denominator, cotan, is going to be a negative cosecant squared x. Now, we really should simplify this because this first term is just going to go away because we're multiplying 0 in that first term. So right here, in simplifying this, we can call this dy dx equals, and then right here we would have just our negative 4 times the negative cosecant squared, so that's going to be 4 cosecant squared x over cotan squared x. Now to give you guys an idea of the simplification we can do, let's take a look at the numerator and denominator. Now, in general, I would say that this is simplified enough. That's as much as I would ask you to do. But if we were looking at this, we could say cosecant is actually 1 over sine. So we actually have 4 times 1 over sine squared x in the numerator. And in the denominator, we've got cotan squared, which is cosine squared over sine squared. And now right here, when we divide by sine squared x in the numerator and denominator, those two things can cancel. And we have 4 times 1 over cosine squared x. And this guy right here, right, we can write as 4 times secant squared x. And that would be the really condensed version of the derivative, right? And one thing I might point out is this guy right here and this guy right here will give us the same numbers for the slope of our original function. Now right here we might have seen this condensed form of the derivative a little bit faster if we took a look at our quotient here and recognized that we could write this as 4 times 1 over cotan x. 1 over cotan x is tan x. So right here we've got 4 times tan x. And right here, the derivative of 4 times tan x is going to be 4 times the derivative of tan x, which is 4 secant squared x. So we might have been able to see a little bit faster if we could recognize that basic identity of 1 over cotan as tan x to begin with. All right, guys, so we're going to stop the video here, and you guys will do a worksheet on this stuff tomorrow.